Well, hello, welcome to MOS Live Ask a Scientist. Today we are talking all about artificial intelligence and answering your questions on the subject. My name is Megan and my pronouns are she and her, and I'm delighted to be here. Now, if you're joining us here on Zoom, you can start asking any questions that you have about artificial intelligence anytime you'd like by clicking the Q&A button on your screen. If you'd like captions, you can access those by clicking the closed caption or CC button at the bottom of your screen and selecting show subtitles. If you're joining us on Facebook or YouTube, unfortunately, we can't see your questions during the program, but we are thrilled that you're tuning in. Now, I am joined by another fantastic educator at the Museum of Science, and I'm going to have her join me now and introduce herself.
Hi, thanks, Megan. My name is Meg. My pronouns are she and her, and I'm also delighted to answer your questions about artificial intelligence today.
Yeah, we're looking forward to it. Now, Meg and I are, as we said, both educators at the museum, but we're fortunate to work closely with the Center for Brains, Minds, and Machines, which is based at MIT. It's a group of researchers who are studying artificial intelligence and human intelligence and how that can inform artificial intelligence. And so we've been able to talk to them about the subject and learn some things from them. So we're looking forward to sharing that or some of that with you today. So again, feel free to start asking questions whenever you'd like, but I think we're going to get started by maybe talking a little bit about the basics. Meg, so can you help us out and maybe give us sort of a definition for what artificial intelligence is?
It seems like a good place to start. So, artificial intelligence is actually a pretty broad term, and it includes lots of different ways to think about simulating human intelligence using a computer. So at the very, very simplest end, you might think about a situation with a lot of clear-cut rules, like if you were a doctor and you saw certain symptoms, then you might be able to check off which symptoms added up to a certain diagnosis and make that call. And that's something that a computer might be programmed to be able to do too. And that is a very super simple version of artificial intelligence. But most of the time, when we talk about artificial intelligence now, we're thinking about something that's more complex than that. We're hearing about kinds of AI that involve something called machine learning or even deep learning. And you might have heard a little bit about those terms. So Megan, I wonder if you could tell us what is the difference between those terms or what do they mean?
Yeah, that's a good question. And I think, and help me out if I get this a little wrong, I'm going to try. So, machine learning is a type of AI, and it's broadly used to kind of assess big amounts of data and recognize patterns in them so that it can kind of figure things out. And so that's a really common type of artificial intelligence. But when we think of artificial intelligence, like Meg was just saying, one thing we really don't have yet is like a really general artificial intelligence, which we can talk about more in a little bit. But so things like machine learning are when computers kind of learn to do things by looking at lots and lots of data and trying to find patterns in there. And then if you think of something, you probably heard the term deep learning, which is sort of the next step from machine learning, where computers or computer programmers use something called neural networks. Which are a type of program that's even better at identifying things by recognizing patterns. And so deep learning uses lots of layers of these neural networks to figure things out and identify things. And deep learning is really what's kind of taking AI to the next level right now. So that's sort of like where we're headed with that. But neural networks are really important in artificial intelligence. So maybe, Meg, can you tell us a little bit more about how they work, since they're sort of underpinning so much of what's going on in artificial intelligence right now?
Yeah, I think this will really help sort of set up some of the background for understanding what neural networks are and why we think of them as sort of learning programs that can learn. So I'm going to share this little animation with you, and I'll explain what's going on here. But basically, if we think about to start how we perceive images. So here is a photo of what to me is like very clearly a dog, and there's lots of different reasons why I think I might pick out, why I believe as soon as I see this that it's a dog. But Megan, like, what do you think when you see this? What about this photo to you makes you think that your brain might recognize it that way?
Okay, so I see a little dog and it's fuzzy. It has four legs. It has two eyes. It has a nose, a mouth, whiskers, little ears.
Yeah, so you can sort of pick out, those are all features that we as humans are super familiar with. Like we've seen other photos of dogs, we've seen dogs in person. It's something that we know generally that they have these kinds of features. They have eyes, they have a nose, they're fuzzy, they have whiskers. And so if you think about how you might teach a computer to recognize a photo of a dog, which is a very common problem among artificial intelligence tasks, right? Image recognition. If you think about how you might go about teaching a computer that, that might be a place to start. You might say, well, maybe I can ask not whether it sees a dog first, but whether it sees like some of these features that dogs have, like eyes and noses and whiskers. But then if you look really closely at that picture of an eye, you might notice that that is also a super complicated picture. So if we break it down even further, maybe we need to start at an even more basic level and think about the kinds of shapes that are present that make up each of those features. And we could go even one step further and go from shapes to something so simple like edges, like just sort of dark on one side and light on another side. And now, when we're talking about the very simplest of patterns, this is where we can start to actually think about asking a computer to sort of look at an image and break it down into these simple patterns. So if we start with our image of a dog and we break it up into lots of little tiny patches, and we feed each of these pixel patches into a neural network that we've built one at a time, we have broken down the problem now to its most simple level, where we can say, where in each of these pixel patches do you see uh, lots any edges at all? So look through the pixels and see if you can find any. And you see it's lit up when it sees one of these paths. And we can do that for each and every pixel patch. And when it sees a certain kind of edge, that little pathway that you're going to see is going to light up. And I'm only showing a few here, but you can imagine doing this for all of the different patches for the entire image. That would be doing this one after another very quickly, because computers are really good at that tasks quickly like this. And then once we've rounded up all that information about where the edges are, that information can be gathered and sort of passed into the next layer of this machine learning model to say, now I know the edges. Do I have any that occur in a combination? Like, do I have both sides and top and bottom? And look, that makes a circle. I can see lots of different shapes. And once you have that shape information, you can do the same exact thing with that, pass it to another layer of processing to say, well, if I have a combination of different shapes, do any of them add up to an eye or a nose? And then finally, at the very end, when you think you have an idea of whether there are any of these features in the image, you can ask the final question and say, is it a dog or is it not a dog? But the thing about these programs is that it's not going to do a very good job the very first time you ask it to do something, because it hasn't been trained yet. And that's okay, actually, because we know the answer when we're feeding it in the training data. So we can feed it lots and lots of images of dogs. And every time it gets the answer wrong, we can tell it that it got it wrong. And that information goes back through the network. And then all of the little decisions that sort of added up to that wrong answer are given less weight the next time around. So by showing lots and lots of examples, we can train it to get better by itself over time. And that's sort of what we mean when we say that a neural network is learning. It's learning to teach us, to teach itself to recognize certain images just by giving it lots and lots of examples and being able to correct it. when it's wrong. So over time, the pathways that lead to the right answer get stronger and the other pathways get weaker. The neural network can teach itself what is and is not a dog. So that's just to give you a little bit of background into how neural networks work. And this kind of program is really useful for lots of specific tasks, like image recognition is one of them. But there's all sorts of other things where having lots and lots of examples to train on can lead to a really productive answer or way of helping humans with their work. So Megan, do you have any favorites in applications of neural networks that you can think of?
Yeah, I can mention a few, and we also have a question here from Heidi asking if there are different types of AI. So maybe we'll get sort of to that answer here, because like Meg was saying, right, we're using artificial intelligence now for a whole bunch of different things. A lot of them have to do with recognizing things, whether it be voices or pictures or things like that. So one really good recent example is something called AlphaFold, which is from Google's DeepMind. And AlphaFold is a program that recognizes the shape of proteins and can figure out what those look like. And so proteins are little molecules that are in our bodies. And they have a whole bunch of different functions. I'm going to try to pull up a picture of one. They're really, really tiny, but this is a computer generated model of what a protein might look like. They have so many different functions, like in our blood and all sorts of different things. But it's really, really hard to figure out what proteins look like. They have these like crazy twisted up shapes that are all three-dimensional. But the important thing about that shape is that the shape of a protein determines its function. And if a protein loses its shape, then it loses its function. So the shapes of these proteins are really, really super important. And things like viruses have proteins. So it's important to figure out what proteins look like, but it's really hard. Usually scientists do this by something called X-ray crystallography, which is where they like basically crystallize the protein and try to actually look at its structure with microscopes. But so AlphaFold, this program from Google, tries to figure out what proteins look like by using artificial intelligence, a neural network that's trained on lots and lots and lots of pictures of proteins. And just recently, they found that this program is actually really pretty accurate. And so it's sort of this really big step in being able to figure out what proteins look like quickly and efficiently, which would have pretty huge implications, particularly medically, in figuring out how to design medicines and things like that, or even trying to figure out what the proteins and things like COVID-19 look like. So that was a really big example. And so there are a lot of other examples of artificial intelligence being used in medical applications, things like even diagnosing COVID-19 or diagnosing things like cancer. But it's also used for other types of biology, like ecology or wildlife conservation. Another recent example, there were some scientists that used artificial neural networks to identify birds. It's really important for scientists who study birds to be able to tell different birds of the same species apart, right? So if you look at these two birds behind me, they're two birds of the same species, and they look really similar, right? But in order to figure out things about the way birds live, like how long they live or where they go, things like that, it's important to be able to tell different birds that look really similar apart. So they were able to develop a type of artificial intelligence that can identify really subtle differences between birds of the same species that look really similar to us, but that this computer can recognize and can help scientists figure out and track birds a little bit more easily. And so there's a lot of applications like that that scientists are coming up with to help them track and monitor wildlife populations. So Meg, do you have any other examples that you really like?
Yeah, one of my favorite recent examples is has to do with astronomy, actually, where there's this really, really cool new telescope that is just about to go live, I think, down in Chile, called the Vera Rubin Observatory. And that telescope is going to have the biggest digital camera ever built for astronomy, and it's taking pictures of galaxies across the universe. And there's so much data that is going to come back from that telescope very soon, that it's kind of a problem for scientists that need to go through it and classify all of the galaxies that you can see in those images. So these researchers built a computer program that can do the classification for you, at least a first pass, built on a neural network. So they fed the computer program lots and lots of pictures of different types of galaxies that we already know about, and trained it that way so that when these huge data sets start coming back, we'll have sort of a handle on how to go through each and every one of those without a person needing to do that first pass. So I'm super excited about that, and it's already starting to be used, I believe. And then I see that there's also a question that we have from Nico that asking, is it true that there's an AI robot dog in hospitals? And this was going to be my next favorite application. So I'm going to share with you a slide with a video. And I don't know about the use in hospitals. I think I might have heard something on the news about that, but I have heard about robots starting to be used in sort of search and rescue situations, especially if there's are places that are kind of dangerous to go into. And this is an example of a demonstration from a Boston Dynamics robot dog spot, where you're seeing down on the lower left-hand corner, you're seeing the map that it is creating from its sensors. It has not only cameras, I believe it also has LiDAR, which is like radar, but using pings of laser light to bounce off of the objects around it and measure how quickly it takes to come back. And that way it can sort of map out the surroundings in real time around it in order to make decisions about whether to turn left or right, or is there a wall there, or is that a set of stairs? So that is a really cool application. So cool, in fact, that it starts to feel a little creepy. So I wonder, Megan, if we might talk just a little bit about whether AI or robot dogs are going to take over the world.
Yeah, definitely we can talk about that. And I just want to note quickly too, while we're on the topic of applications, that Scarlett also asked, could AI be used in medical research? And definitely, we touched on that a little bit, talking about how, there were some scientists that were trying to apply artificial intelligence to diagnosing COVID-19, or trying to identify the proteins in viruses like SARS-CoV-2. So yeah, definitely being used in medical applications. So thank you for that question. So back to the robots. Are robots going to take over the world? So in talking with the researchers in AI that we get to work closely with, the answer to that is not anytime soon, which is comforting. But the big reason for that is that although we have programs that sort of get at artificial intelligence, like neural networks and things like that, that can recognize images, or that we can program robots to do certain things, we don't have something that's called like general artificial intelligence, where we have a machine that can really think and feel and do all the things and make all the decisions that a person can using their own human intelligence. And so that's something that would be a long way off. Some scientists think it's forever away. Some scientists think it's decades and decades away, but it's not something that we're kind of on the cusp of. And so right now we have programs like robots that can do things, and we have Alexa that uses voice recognition to try to answer your questions, but there's still a lot of programming behind it, and she's not really thinking for herself when Alexa answers your questions or finds the song you want to hear. That's really just your voice being sent to the cloud, and it goes through programs and it recognizes patterns in that language, and then it Alexa figures out how to answer that. But in terms of robots too, so robots can do a lot of amazing things. And I'm going to pull up a quick video for you. Again, this is from Boston Dynamics of their parkour robot here. I hope y'all can see this. Oh, hold on. We're going to show this one in a minute. I'm going to pull up a different video for you. Here we go. Okay. Whoop. This is still here. Oh, here I have two videos open here. Okay, so I hope you can see this. So this is the Boston Dynamics parkour robot that can do some really amazing things, right? It can be programmed to jump over obstacles, um, run over things. It can even do like gymnastics. I think it's about to do a backflip. Yeah, it can hop up on top of things, or maybe it's gonna, yep, here we go. It's gonna do a backflip. So pretty
Wow.
amazing, but still, even though these robots can do these really cool things, they have to kind of be specifically programmed to do them. They can't just kind of suddenly decide, I'm going to do a backflip now, like a person could if you could do a backflip. And so what happens when robots sort of more try to think for themselves is that, and hopefully now this is switched to the other video. I saw an example recently of, even like small children who can make these kinds of decisions that it's hard for robots to make. I saw an example of an experiment where someone was trying to get into a cabinet with a box, and they just kept bumping into the cabinet because the doors were closed. But a 1-year-old knows to come over and open the door for them, but a robot doesn't know to do that. And so here's kind of an example of that, where if this robot was going to try to put a box on a shelf and it needs to sort of figure out how to do that on its own, it doesn't do very well. It's actually a really difficult task, and it just fails pretty bad. So it's really difficult to program robots to do the things that we want to do, all of the things that humans can do. So we're not quite there yet, but we're coming up with new ways to improve on robots every day, but we don't really have something like you see in the movies where they have androids that can, think and feel like humans. And we have a couple other questions here about robotics. Nico asked, is AI something that is real in robots? And hopefully we just answered that question for you, where there's AI that's applied to robots, but we don't have like a generally intelligent robot. And then we have another question, which is, what is the smallest AI robot in the world? And Meg, I have no idea.
I I have to say I have no idea either, although I would just say, I don't know, this is a loose definition of the word robot, but there's certainly like things like we carry around, like my smartphone every day that builds on our AI intelligence. So I feel like the applications that we use in our everyday lives are going to feel a lot more mundane than what we've been led to believe in science fiction movies and about robots and that kind of thing. But just the search function when I'm trying to find something on the web uses artificial intelligence to try to first of all figure out what it is that I'm asking for, and then to try to find the right search result that answers whatever it is that I wanted to know. Each of those, there's just such a vast amount of information on the internet that you need something that has all of these like layers in these neural networks, this deep learning, in order to find all of the patterns that help solve these problems so quickly. So I would say I don't know if it's the smallest AI robot in the world, but just to think about carrying your phone in your pocket and all of the wonderful things that it can do, that's pretty amazing to me already.
Yeah, that's a great answer. I didn't even think of it that way. That's great. Thank you, Meg. Um, so one thing I want to make sure that we address is some of the other problems that there are with AI, which is bias. So Meg, can you tell us a little bit about problems with bias in AI?
Yeah, absolutely. So as we were saying with the training data, neural networks are really only as good as the data that you train them on. So if you don't have a very complete data set or range of scenarios that you want your neural network to take into account, then it's not going to do a very good job in the real world. And there are some really unfortunate implications of this that impact different communities more or less than others. And it's something that the whole AI community really needs to be aware of and work toward, sort of including everyone at the table to begin with, but then also really thinking carefully about how these applications are used. And I'm just going to show you one example in the category of facial recognition. This is a researcher who was a grad student at MIT some years ago now, Joy Buolamwini, and she noticed during her research in artificial intelligence that she couldn't get the facial recognition software to recognize her face. So she's sitting down here in front of the software and nothing is happening. But if she puts on a white mask, all of a sudden it sees that she has a face. And that led her to found something called the Algorithmic Justice League, which is dedicated to sort of improving these bias issues in AI. But it's something that I think just that very visceral example, like we need to be aware of, and also, I mean, and just always seek to include better and better data sets when we're thinking about these applications and who they might impact more than others. So that's one issue. Another issue is the safety of self-driving cars, for example. We often get questions about whether those are going to be a real thing anytime soon. And I think a lot of one answer to that is that they kind of are a real thing. They're being tested extensively now, but sort of in mostly safe environments, because even with the few examples where we've had self-driving cars on the road, we've probably heard of some accidents and some terrible things. And that is a big problem for the self-driving car industry too, because they don't have tons and tons of data to train on. In fact, a lot of companies have turned to trying to create synthetic data so that they can run, a gazillion scenarios for the cars, like way more than they have actual training footage for, or something like that. But that's definitely another problem that artificial intelligence just has to consider really carefully moving into the future.
Yeah, so it looks like we have a couple more questions here. One from Paul about fractal-like art and being generated by neural networks. And I honestly haven't heard of that. So that's really interesting. Thank you for that question. But I don't know if you've heard of that, Meg, but I
A
know
little bit.
yeah, go ahead.
Yeah, I mean, I think what I think of when I read this question is there's like a Google DeepMind image uh, thing that you could actually play with at home, I think, if you search for it. But what it does is it allows you to upload some image, and it asks this DeepMind neural network what it thinks it's seeing if it just iterates over and over again. So a lot of times what we're asking it to do in recognizing an image is tell us what's in the image. But in this case, you're sort of asking it to create an image based on what it thinks it sees initially. So it's iterating. And what happens is you end up getting these really freaky images because Google image search, for example, is really good at recognizing parts of faces like eyes and noses. So if you upload an image into this DeepMind thing, a lot of times what you'll get is it'll keep iterating and thinking that it sees more eyes and more eyes, and it'll give you back what it thinks it sees, and it's like a monster. So it is fun to play with, but it is sort of a neat application, or a different use for sure for neural networks. Definitely amusing.
Yeah, cool. And then we have Kaylee has asked, in the future, what jobs do you think AI will be used for? And I think, people have worried about whether AI is going to, take over and automate all of our jobs. And we've talked to some researchers, right, Meg, who are not as concerned about AI taking over all the jobs that there are, because again, there's a lot of things that, we maybe really need human intelligence to do, or prefer to have people doing. But I think something that's really interesting is just how much we can still learn about AI. So I think something that's going to be important is more people who can program artificially intelligent machines, and who understand how to do those things and apply them. Like they're even creating grocery stores that are like totally automated and based on AI. You just sort of like walk in and walk out with your groceries, and it all does things for you. And so I think, well, maybe there may not be as many people taking working behind like the cash register. There's probably so many people that they need to like create those programs, and discover new things. There's a lot of people who are working just to like learn more about our own intelligence so that they could apply that, to artificial intelligence. I don't know if you have anything else to add to that, Meg, before we go.
Yeah, absolutely. I think that there's really exciting parallels between how our brains work and how we hope to be able to add to artificial intelligence. And there've been a lot of breakthroughs just recently about things that came from discoveries in brain science that when you add them to the programs on the artificial intelligence side, it actually seems to make them work a little bit better too, which I think in turn tells us something about our own minds, which is really interesting.
Yeah, great. Well, thank you so much for joining us. That is all the time we have. So, Meg, thank you so much, for answering all those great questions and for sharing your knowledge. Thank you. And we have a lot more going on over at MOS at Home. So please do, go ahead and check us out online. And if you enjoyed this program, please consider supporting the museum by visiting us at engage.mos.org/welcome. And keep asking questions and joining us. And we will see you next time. Thank you. Bye-bye.